the next speaker is Yana. We are going to jump to the next one because Renate is hopefully joining backstage soon. So Yana, I'm very happy to have you here on the stage and excited to find out more about Mobies. The stage is yours.
Thank you. Hi, everyone. This is joint work with Alexei Ivchenko, who is a Russian engineer. Let me tell you the story of how our collaboration happened. So several years ago, I had this kit for building and exploring math called geometers, and it's different shapes. And they snap together like this. And Alexei saw this on one of the Facebook groups, and he said, well, I have an idea of something to add to this, and you'll be able to make hexaflexagons out of it. And so hexaflexagons are these things here that are extremely fun. And so I thought, well, sure, I want to make hexaflexagons out of geometals. And this is how Mobies were born. So for the rest of the talk, I'm going to switch to my other camera so that, I'm going to switch to the camera so you can see my hands. Here we go. Okay, so this is how Mobies were born, okay? And the reason it's called a Mobie is that it is, you can see that it's topologically a Mobius strip. And why is that necessary? Well, here's what we were able to make out of it. This is a hexaflexagon, which actually topologically is a Mobius strip. So that was important to be able to do that. And so here's how it works. And you can disconnect it. And so it seemed that with all we needed was a spacer that was topologically a Mobius strip, and we could do all these great things with it, okay? And we could also do things with squares, like this tetraflexagon here. And so all is well and good, but then the story has a continuation because I started wondering if we could do things with actual polyhedra, like make hinged polyhedra. And it turns out that you can make them, you can kind of use them as spacers. And so you can actually, there's a little space right here, and it allows you to make a hinge, okay? And also, you can use the property that some polyhedra have where you don't need every single face in order to make the structure stable. And so you can use the free edge to make hinges like this. And so what do we have here? We discovered completely unexpectedly that we could make things like this. So you perhaps might recognize this as an infinity cube. And so it's particularly fun when you can do this infinitely many times, and that's the title of the talk, when it's cyclical. And the other thing we can do that we thought was really fun is this infinite ring of, so these are each square antiprisms, and they're hooked together like this. And I got this all from a book by Gene Peterson. And in that book, they're actually square elongated dipyramids. But I figured that this part, the dipyramid part, could be just chopped off. It's not necessary. And so we hooked them up like this. And this is quite mesmerizing to do. And so this made us wonder what else might be possible with these Mobies and polyhedra, and we would invite the audience to tell us any other ideas that you might have, because we're just at the beginning of this project, and and we're wondering if there are more things that you could do.
Thank you.
And I will write in the chat a link to all this.
Okay, great, Yana. Thank you very much.